Hello everybody, welcome back to another Weather Wednesday. Look behind me, we got our Science on a Sphere back. This is awesome. Come to find out that last week when we tried to do our Weather Wednesday, our Science on a Sphere wasn't working. Well, we learned that Science on a Sphere wasn't working anywhere in the world. So it was on NOAA's National Oceanic and Atmospheric Administration. It was on their side, the technical issues. We solved those, and now we are back. Look at this beautiful sphere. It is a lot of fun to have this back. So what I'd like to do is talk a little bit about review what we talked about last week. And then I want to try something new with you guys today, trying to do a little hands-on thing that you guys could probably do at home. But anyway, just let's take a review. Let's take a refresher of what we talked about last week. Last week, if you remember, the topic was derechos. There was a derecho that hit the Midwest. Right there, you can see a derecho. Well, actually, that's from the one that hit us before. But here's the one that hit the Midwest there. Caused a lot of wind damage. Knocked power out for over 1 million people, 1 million houses and businesses. It was quite the gust front. And if you recall, a derecho is a wind event that is about at least was 250 miles long, travels at least 150 miles, and produces wind gusts over 58 miles an hour. There were several of those that hit the Midwest there. Let's take a look at, here's just a couple more pictures that I prepared last time. This is a composite radar image. You can see the time here. The time here was 8 a.m. when it developed on the west part of Iowa here. And you can see every hour, you can see this band travel across Iowa, through Illinois here, and on to northern or southern Michigan, northern Illinois, and Ohio there. So it lasted the entire day. Notice that it started at 8 a.m., lasted all the way till 7 p.m. is where my picture goes. It lasted until 8 p.m. All day long, that derecho traveled across the Midwest. There is an amazing picture of it kind of traveling across a suburban area. And here is that famous grain silo picture. I showed you that last week. Definitely knocked several trees down, knocked some power out. So let's take a look at what that looked like on satellite imagery. All right. So we're going to go to our blue marble here, look at the clouds, and fast forward to that incident that traveled across the Midwest here. And you can see it right here, that big puffball right there, as it travels across the Midwest there, and just went all the way across. And you can see it create kind of that bow effect before it dissipated at night. That's what it looked like on satellite. In just a minute, I'll show it to you again on our higher resolution satellite image. And moving on to the most recent satellite imagery. What I want to do now is show you what is going on around the United States and around the world, weather-wise. Let's take a look at this. Starting in the southeast here, Florida. It looks like Florida has been getting daily thunderstorms pop up. That is usual, typical this time of year, where you can see those thunderstorms just pop up during the afternoon parts of Florida there. Over the Midwest, it's been pretty hot and muggy. We had some visitors here at the Discovery Center from Missouri, where right now, during the month of August, they renamed their state as Misery because of the heat and humidity there. You can see thunderstorms pop up once in a while in the afternoon. It depends on a couple of things. As we've talked about here before, and we'll talk about again in the future, you need certain ingredients for thunderstorms to form. One is humidity. You need the moisture in the air. Two is you need that energy rising up, and then you also need some wind shear. So you need some winds that are winds aloft that are conducive for thunderstorm formation. So a few days ago, there was that over the Midwest, but yesterday there was not. It was a pretty calm day throughout the United States. As I'm looking across, as I continue across going west on the United States, we see, watch this cloud band right here. There's not a whole lot of clouds in this, but if you look closely as I rock this back and forth, do you notice it rotating a little bit? Which direction does it rotate? Which direction does it go? Does it rotate clockwise to the right or counterclockwise to the left? If it rotates to the right, which it does, watch carefully, it rotates to the right, that indicates this is a high pressure system. Okay, so that is high pressure there, and high pressure in the summer typically brings high temperatures, and the Southwest has been experiencing some very warm temperatures. In fact, the Death Valley, California, which is known for its hot temperatures, just set a record of 130 degrees over this last weekend. 130 degrees. It's hard to imagine what that would feel like, but Arizona, southern Nevada, Southern California has been experiencing that all week, where they have been in the 110s. I know that in Arizona, they've been having days in the upper teens. That's 100 and teen there. Upper 100 and teens and down to a much cooler 90 degrees at night. I don't think I want to experience that. Thank you very much. Also, we can see down here off the coast of Mexico there is a hurricane that is off the coast. Scientists are predicting that will continue to decrease before it hits land. However, it will bring some significant rainfall and a little bit of wind on the western part of Mexico there. And then lastly, Pacific Northwest here, we see a low pressure system, just a small low pressure system, not too strong, but a low pressure system has a tendency to bring clouds and moisture. So there will probably be some chance of a little bit of rain coming to the Pacific Northwest here over the next day or two. Looking around the rest of the world, I'm looking to see if there's any significant weather. If you have been paying attention to our Weather Wednesdays or Weather Worldwide, you know that Southeast Asia has been experiencing a very strong monsoon season with a lot of rain causing flooding in Southeast China and India, Malaysia there. And that looks like that is continuing. As you can see, when I rock this back and forth, you can see the clouds develop every single day, bringing still continuing to bring rain and moisture to that area. And if you were to continue looking at the forecast, again, it looks like conditions are favorable for rain to continue to form. So keep them in mind. See if there's anything you guys can do to help them out as they battle through these flooding events there in Southeast Asia there. So now this brings up, let me bring up my high resolution image, satellite image. This comes from our GOES 16 and 17 satellites way out in geostationary orbit. These are nicknamed GOES East and GOES West. And what they do is they sit out at geostationary orbit 22,000 miles off the surface of the Earth, and they are just staring at the Earth. They are in a special orbit so that we can see everything move underneath the satellite there, and they don't lose their view of the Earth. So we can see the weather change. These latest GOES weather satellites are the most advanced and most capable satellites we've ever had for weather, for watching weather over the United States here. And as it's progressed, you can tell the difference from the last satellite image. You can tell this one has a higher resolution, basically more pixels per image. And we're going to talk about that here in just a minute. So going on to the most recent satellite image right here, August 19th, that is today. Looking at the satellite imagery here, you can see that really beautifully formed hurricane there off of the west part of Mexico. And you can see that low pressure system off the Pacific Northwest. So you can see that the GOES 16 and 17 image produces a very high resolution image that we could even zoom in on. We could zoom in on and see really close up. Now, here it is right here. Look at the details on that, guys. Pretty amazing details from this satellite image. So this begs the question, how do satellites see? How can they get that image? How does it work where they get that image and then they transmit that data to the Earth and we turn that into pictures? If you follow us, you'll notice that the satellite imagery is usually less than 3 hours old. That means that the satellite, which is 22,000 miles away, takes the picture, packages it up, sends it back down to the United States. I think the downlink site is in North Carolina or Virginia. Takes that data, sends it to all of the SOSs around the world, and then those SOSs project it onto our sphere all in less than 3 hours. That is a pretty amazing operation, pretty amazing event. So in order to kind of demonstrate how satellites work, I would like to take you guys to our gallery here and show you a model of a satellite and demonstrate how satellites work. So bear with us here as we try to transition to another place, and follow me as we go to the Discovery Center. So hang on and see how this works. All right, follow me here to our gallery. Welcome to the Discovery Center gallery here, where we have a number of space items, space artifacts, one of which is this big satellite here, which you'll see over my shoulder in just a minute. But you'll see this huge satellite. Guys, this is just a half-scale model here in just a minute. A half-scale model over my shoulder. Imagine this thing, which is much bigger than myself. Imagine this thing double in size. And our geostationary, our GOES 16 and 17 satellites are literally the size of cars. So can you imagine a rocket launching a car up into space to look at us here on the Earth, to look at our weather? Now, hopefully you guys can see me okay, because what I'd like to do is demonstrate to you how satellites work. On board a satellite, you have a special detector. No, it's not an egg crate, but what it is called a CCD, or a charge coupling device. On this CCD, there are a number of detectors that detect light particles called photons. You can imagine that each cup here represents what we would call a pixel in an image. The more pixels or the more buckets you have, the higher resolution the imagery. We call this activity here at the Discovery Center, we call this pennies from heaven. That's what we nickname it. Imagine these pennies as being photons of light. These photons of light can be emitted from things like stars or cities or different light sources, or they could be reflected off of the object. So it could be reflected off of the moon. That's why the moon is so bright. Or it could be reflected off the clouds. So imagine the light reflecting off those clouds and then hitting the detector which is on the satellite, hitting those detectors and basically falling into those cups. Remember, each of those cups is a pixel. And so based on the number of light particles that enter that pixel, that tells this, the image, the computer, how bright that object is. So the more pennies that hit that detector, the brighter that imagery. So clouds, which are very bright, would have a lot of photons entering that particle. Maybe like water or land that doesn't reflect so much light might be a little bit more empty for that pixel. So the computer then takes all of those pixels, which are literally millions of pixels, which we call megapixels, takes all those megapixels and puts it together, called binning, where they take those photons, they add them all together, and then create an imagery. Again, once again, the smaller those buckets and the more buckets you have, the higher resolution that you get. Well, I hope that you guys learned a little something today, followed us here at the Space Foundation Discovery Center. We encourage you to tune in to our website, discoverspace.org, to find out more hands-on activities that you can do at home. Also, if you have any questions about weather, we encourage you to send those questions in to us here at the Discovery Center. Next week, we're going to take a look at some of those questions and see if we can answer anything weather-related or space-related. So until next Wednesday, thank you for watching, and we'll be back with our next Weather Wednesday. Talk to you later.